Hi, physics class. It's Mr. Mellinger for your distance learning lesson for Tuesday, May the 12th. And we started on the subject of waves yesterday on Monday, so I'm going to continue with that. So we left off with this slide explaining what frequency means. And frequency is how many cycles of a wave pass a point each second. So if you look at the wave on the top, that has a crest. That's crest 1 is directly beneath where you're standing. You're standing at point A looking down on that wave, and that wave is moving to the right. 1 second later, you look at the image down on the lower half of the screen, and it shows that crest 2 has moved over below you. So it's kind of a before and after picture, since I can't show motion on the screen. And what this means is that one cycle of the wave passed you and it took 1 second. So that's a frequency of 1 hertz. What is a cycle? It's a movement through the wave along the yellow line from crest 1 down the wave and back up to crest 2. Or it could be from any point in the wave to the same exact point on the next wave over. But it's always easier to identify the crest, the top of the wave, so from top to top. Alright, example of frequency. At 0 seconds, crest 0 is at point A. So again, you're standing at point A looking down at this wave as it's moving underneath you to the right. At 1 second, crest 2 is at point A. So you can see the wave down at the bottom. It's the same wave, and it's moved over to the right, and now that the crest that we've labeled crest 2 is directly below you. How many cycles have passed? Okay, so the answer is 2. It went from crest 0, it went down and came back up to crest 1, it went back down and came back up to crest 2. So from 0 to 2 is 2 cycles. What is the frequency of the wave? Well, frequency equals cycles per second. And so it's 2 hertz because 2 cycles passed you. And over on the left you see the time, 0 seconds to 1 second. So it took 1 second for that to happen. So 2 cycles per second is 2 hertz. And finally, what's the period of the wave? Now, I haven't introduced this yet, and I'll do that actually on a later slide, but let me go ahead and give that to you. It is the reciprocal of the frequency. So in this case, the frequency is 2, and if you take the number 2 and you flip it over, you have 1/2. 1/2 is the reciprocal of 2. So that means the period of the wave is 1/2 second. So what frequency asks is how many cycles passed a point in 1 second, or each second. And in this case, it's 2. What the period asks is it flips the question around. It says, how long does it take for 1 cycle to pass a point? So if you think about it, if 2 cycles pass each second, then each of the cycles had to take 1/2 a second. The first cycle took 1/2 second, and then the second cycle took another 1/2 second, so that's 2 cycles and a total of 1 second. So period is how long it takes 1 cycle to pass a point. So there's the formula. I should have put that up first. So period is 1 over frequency, and there it is, 1/2 second. Okay, on this slide, so this is a further illustration of the concept of period. So the period of a wave is the amount of time it takes 1 cycle to pass point A. If 4 cycles, they're not really wavelengths. Wavelength is the distance from crest 1 to crest 2. It's a straight line from 0 to 1, 1 to 2, 2 to 3. That's a wavelength. The cycle is really one movement through the wave. But it starts at the same place and ends at the same place as a wavelength. So if 4 cycles pass by point A in 1 second, then it takes 1/4 of a second for 1 cycle to pass. So again, look at the illustration here. If the wave moved from crest 0 to crest 4 in 1 second, then to go from 0 to 1 would be 1/4 of a second. To go from 1 to 2 would be 1/4 of a second. To go from 2 to 3 would be 1/4 of a second. And to go to 3 to 4 would be 1/4 of a second. That means each cycle takes 1 second to, 1/4 of a second to pass. And you can see that illustrated down below. So 4 cycles per second means that 4 cycles pass in 1 second, or 1/4 of a cycle passes each second. And so you can see how that works down there. Okay, so again, the period is the reciprocal of the frequency, and the frequency is the reciprocal of the period. They're reciprocals of each other. You just flip one over to get the other. Okay, this is really, except for that period frequency equation, this is really the only equation that's used in Wavespeed. And what it says is this: the wave speed equals the wavelength times the frequency. So wave speed, we're abbreviating with the letter V, so think of it as velocity. Speed, velocity in this case, we're going to treat the same. So it's the wave speed or wave velocity equals the length of the wave, the distance from one crest to the next, times how many of those waves pass a point each second. So a longer wave that passes, that it has more cycles passing each second, will have a faster wave speed. So if you count the number of cycles, wavelengths, that pass point A in 1 second, and then multiply this by the length of each wave, and that is the Greek letter lambda, and it's looks like a little man walking with his head cut off, but it's the Greek letter lambda, and it's the abbreviation for wavelength, how far it is from one crest to the next. So if you multiply by the length of each wave, lambda, you will get the speed, velocity of the wave that has passed point A in 1 second, and this is called the wave speed. Okay, so there's the equation again at the top. So it's wave speed equals wavelength times frequency. So here's just a simple example problem. A wave with a wavelength of 2 millimeters has a frequency of 5 hertz. What is the wave speed? So you see an illustration down at the bottom. There's a frequency of 5 hertz. You see 5 cycles are going to pass point A in 1 second, and each cycle or each wavelength is 2 millimeters long. So if you're looking for the wave speed, there's the wavelength and the frequency. 2 millimeters is the length of each wave, and the frequency is 5 hertz. 5 cycles will pass a point in each second. So you use the formula, you plug in the numbers, and you get 10 millimeters per second. So that's how fast that wave is moving. So here's a summary of everything we've talked about so far. So the abbreviations are: for frequency, it's kind of a scripted F, and the unit of measure for frequency, that's cycles per second, or hertz. Period is a capital T. Think of time, it stands for time. It's how much time does it take for one cycle to pass, and it's the reciprocal of the frequency. Wavelength, and that letter is pronounced lambda, and it's measured in meters or millimeters or nanometers when you get to light waves, but it's a distance. It's a length. Length is a distance, just like what we talked about in earlier topics of physics. And wave speed, which is V, think of velocity, is meters per second. So down below are the only formulas there are for waves. There's actually one small one later on. These are the formulas used for waves. So wave speed equals wavelength times frequency, and period is 1 over the frequency, or frequency is 1 over the period. Okay, so that takes care of our second lesson. Just to go over some of the terminology and a couple of the equations that you'll use for waves, and we'll continue the study of this. Eventually next week we're going to get more into specific types of waves like light waves and sound waves. This week we're covering just the basics of waves and just some terminology, so it's just going to be some PowerPoints and answering some basic questions. None of these assignments should take more than about 20 to 30 minutes at the most. Okay, so we'll see you on Wednesday, May the 13th. Have a good day.